done up. So starting up with one example that is the most important, and it is based on production allocation problem. That is production allocation problem. How this problem is being solved up. So start all these equations with me. I will share you simple case studies. Let's see, are you able to do that case studies or not, right? So one case study is depending on your production allocation problem. What type of production allocation problem can be possible? So start writing, like I can take one example or case study with you. A firm is there, right? That is having a three product. A farm is producing basically three products, or you can say product one is there, product two, and product three. All these products are processed, like they are all processed on different, how they are processed on different machines, right? And we can say we have again three machines over there. Machine 1, machine 2, and machine 3. And when the products are being processed up in the different machine, the manufacturer that is producing all this bit required that one unit, it is given over there, that one unit of each of three products and the daily capacity of these three machines is given to you, right? Whatever the time required, manufacturers provide you the time requirement of all these units, and the three, or whatever the capacity of these three machines, it is all given to you. Now, considering that information to you, all the time requirements and all the details, let's see if we are able to find out the situations of that linear programming. So, write it over here. We have given a three machines, right? Machine 1, machine 2, machine 3. And we're given a time per unit in minutes, right? For all these, the product 1, product 2, and product 3. And the maximum capacity, how much we can do from all these machines is also given to you. Maximum capacity, that is minutes per day. Right? Now, what this information, how we can help us? So, write down whatever the type of information is given to us. We are given machine 1. When the machine 1 is done in one product, it will take 2 minutes. Right? If it goes to the product 2, how much minutes is taking? 3 minutes. At 2 minutes over here. When the machine 2 working in the product 1 is taking a 4 minutes. No time is taking in the product 2. That means machine 2 didn't work for the product 2. And the product 3, it required 3 minutes. Right? Machine 3, when going in the production for the one, it took nearby through 2 minutes. Here it requires 4 minutes, and there is no time. Okay, and the maximum capacity is given to you is 440, 470, and 430 given. Now this is the information provided to you that we have three products and we have to. Now what you have to do? You have to determine, write down over there, have to determine the daily number of units to be manufactured for each product. And you have also given the profit, right? Profit per unit of product 1, 2, 3. You have three products and the profit per unit is also given to you. Say example, we are taking an example or case study that is 4 rupees, 3 rupees and 6 respectively. Right? And we also assumed that the amount of products are consumed in the market, that is as per the units. And now you have to make a formulations with this information. So you have to formulate the linear programming. Formulate linear programming model. That is also called as LLP. So how we formulate? Again, step by step, we use all the steps properly and are formulated. What are that steps? First of all, indicate me what are the steps. We have write down and recall all the steps. First step is from the study of the situations, what we have analyzed it, we find out the key decisions to be made up. The first situation, key decisions to be made in this event that we have given a three products and the extents are also permitted to vary, right? Step number two, that we have the symbols for the variable that we have noticed up. Let us extend the amount of the product, that the product 1, 2, 3 are using. We take in an example. Let x1, x2, x3. You can take x, y, z, it doesn't matter. In the step number three, we express the physical alternative mathematical in the form of their variables. And the physical alternatives are those which are basically feasible, economical, and financially that can be possible. And in this situation, in the given situation, we have the x2 and x3 units respectively. So again, the most important constraint as a non-negative constraint that the value of x1, x2, and x3 should be greater than equals to 0. Excuse me. Now stepping up forward, that will be the step number 4. You have to properly mention your objective function that is always in the quantitatively word. And it always expresses your linear programming function that permits the objective, that is to maximize the profit, and it is always indicated with the word Z. The last but not the least is that putting all these constraints and the time per unit with the labor constraints that is influencing your factors and we can say limitations. They generally occurs what are the constraints that the resources we are available or what are the requirements or the demand. So express these all the equations in a linear equations or inequalities in the terms of variable. Okay, so by step I'm doing with you. Hope you able to understand what are the different steps of all this. It's better that you all start up with me only, or either you can, like, hope you have already done in your mind that we have to do all these things. So first point is the step number, if I'm writing in the step by one, first step is what we have to study. We have to find out the key decisions variables, right? And we have determined that the key decision variables over this question is product 1, 2, and 3. If I'm talking about the step number 2, what we have indicated in the step number 2, that we taken a symbol. Like we have taken x1, comma x2, comma x3 are the units. We are assuming it as an units for product 1, product 2 and product 3. Right? Now with the next step, that is the step number 3, what we have on a third step, our main objective. What is our main objective? In this also our objective is to maximize the profit, and already we have given 436 as we have heard of. So write it over here is 4x1 plus 3x2 and 6x3, right? And your next step for this will be your constraints. Your constraints. So what are the constraints? We have the different types of basically three constraints in this. And what are that? That's the machine capacity. But the most important thing is the machine capacity and all the timing requirements for this. As we have the different timing, machine 1 has a different capacity, 2 is having a different capacity, 3 is having a different capacity. So we have to make all three constraints together. First one by one we have to make a constraint. The first constraint is your 2x1 plus 3x2 and your plus 2x1, and the one is the machine has a capacity of maximum 440. Next one is your 4x1 plus, as we have just seen of that machine 2 is not working on the product 2, that's the product 1, so we take it as 0 x2 or you can ignore it also, and 3x3, and the maximum capacity over here is also 470. The third equation, third constant is 2x1 plus 5x2 plus, again it is not required in this, still write it over there, and the maximum constraint is 430. Last but not the least is your non-negative constraint. Always remember we have to take this on priority basis. Non-negative constraint at the value of x1, x2 and x3. The units of all these values should be greater than equal to 0. So this is the way have we formulated one case study that is related to your production allocation problems. Hope you are able to understand this point. Done. Now I am coming forward with the next example that is related to your next case study, and that case study is related to product mix problem. We have the different case studies of the linear programming. It's up to you how much formulations you are able to do, right? Now, in this case, we just take one example, like what example we can go off so that it can be help you to understand in more ways. Like we take it like, okay, note down a factory as we are taking out the product. So we are taking example like a factory. A factory manufacturer is there, right? A factory manufacturer which producing a two product. Now we have given a two product as we have taken a product mix. So two products are there, A and B. Right. The manufacturing units of A. Again, it requires labor and machine. We just have done this question, but still I'm telling you, I'm preparing a box in front of you. Hope you're able to understand properly. Okay, so I'm just writing over here that we have two products, A and B, when manufacturing products too, and the labor. If I say about this is my product, okay, you can write it in this way also in vertical way. Okay, now in this scenario, as I'm using in a second time, so I use in this way. Okay, now writing in a horizontal way, this is my product. Start writing with B. We have two products A and B, and we have the different resources as well as we can say it in the different units we have. One is my machine, right? First one is your machine, and second one I'm taking it as my labor. For product A, we require, say example, 1.5 hours of machine, and for the labor, I can say 2.5 hours of labor. For manufacturing the product B, we require 2.5 hours of machine, and we require 1.5 hours. These are all in hours. Now we're coming up next point, availability. The most important thing. Are we having an unlimited machine hour time? No, we have only 300 hours we can use for the machine. And if I'm talking about the labor, how much labor we are available having? 240 hours of labor we are having. Now you have two constraints over here. What are the two constraints if I'm talking about the constraint? So what are the two constraints over here? We have two constraints, that is my machine time, and the second constraint is your labor constraint, right? And one more information again we have given, that's the profit, right? We have the always we have this type of information, what are the profits with the product A and making. So I'm writing over here, say example in this only, profit made by A is given to you and that is $50, and the profit made by B that is given to you is 40. Now with this information you have to prepare a linear programming formulation. Are you able to do this formulation? Start doing the formulation if you are able to do with this information. Now we have already done many formulation process. So how we start up? Taking the same way, we have considered it first, we write it like X1 will be the number of units for the product A manufacturing per month, whatever the information. X2 will be the number of units for B manufacturing per month. Then we have taken the next point, that is an objective maximization, and what is that? That we want to maximize the profit. And how much profit you want to maximize? That is 50 for producing a product A, and for producing the product B is 40. So we write it 50x1 plus 40x2, right? But we have the subjective constraints also there, that is a machine hour, and machine hour is 1.5 hours for x and y. So 1.5x plus 2.5x2. Or if you're writing it x1, x2 or xy. But we have the limitation, maximum is 300. So 1.5x1 plus 2.5x2, it should be less than equals to 300. And for the labor constraint, 2.5x1 plus 1.5x2, that should be again less than equals to 240. And the non-negative constraint is always there, that is 2. That's your x1, x2 will be value should be greater than 0. Hope you are able to do the situation, or shall I help you in making this formulation? Okay, I'm helping you. Hope you get it, but still just add a little information. Like what we have to do, what we have to write it. X1 is the number of units of product A manufacturing, and X2 can be the, you can take it X and Y, it doesn't matter for that. Okay, that's a variable. Number of units of product B manufactured. Right? Now what we have to write it? Your main purpose, that's an objective. That is the most important thing, your objective function. What is that objective function? That is a Z, indicate with Z. And you write it maximization, that means it's a profit, or you can write in a bracket also. Z is equals to how much it is given, that we want to make a profit of 50x1 plus 40x2. Now we write it over here as a constraints. Two constraints are there, labor and machine. So write it over here for labor constraint. What are the labor constraints over there? 1.5x1 plus 2.5x2 is less than equals to 300. And second constraint is there for machine constraints. That is, how much machine constraints are there? 2.5x1 plus your 1.5x2 is less than equals to 240. And the last constraint, that is a non-negative constraint. Non-negative constraint that the value of x1 comma x2 will always be greater than equals to 0. So this is the second numerical, second case study we have done related to the product constraints, right? Coming further, as we all increasing up, we can go for the next case studies and next case scenarios, and that case scenarios can be very easy. You just have to understand what can be the problematic in the linear programming model. The more you make the formulation, you will get it more like learning problems, right? Now I'm giving you one more example over this. Like now we take an example like okay, we're taking an example in this way. We have three products now: product A, product B, and C. Right? And this product always required a raw material, but the quality of raw material varies. Right? We have three categories of raw material, and that is P, Q, and R. Now, this is a different case scenario. You have to understand it. That we have three products, right? And the manufacturer required three qualities of raw material, and the quality of raw material varies like P, Q, R used. These are being used. Okay. Now the information for the different points are there. How much we are required for the product A required the P quantity of raw material is no, not required. What about this? It is required 20. We require like product A requires the R unit at 50. About if I'm talking about the B, it is required 20, 30, no requirement is there. Over here it is 30 and over this it is 20 and now we required a 40. So this is the information given to you, right? Now what else we have given? We have given the maximum raw material availability. So note down over here what are the availability which is available in the market for the manufacturing of these products. So product A available is 80 units. It is all in units, right? This is 80 units. If I'm talking about the product Q, it is 100 units. If I'm talking about the product R, it is 150 units, right? I'm also given a profit, so write it over here as a profit. What are the profits is given to you is per unit as rupees 5. It is always in rupees, right? And the profit for the product B is 3. Profit for the product C is 4. So these are the information is over to you and you have to make a linear programming formulation. So we will to do how we can do this version, same scenario I'm just discussing first. First point is always a decision variable. Take a decision like x1 will be the number of units of product A, x2 will be the number of units for the product B, x3 will be the number of units for the product C. Right now, writing out your objective function. Since that the profit per unit is given to you, we take it on a profit function is maximization. That is maximizing x is equals to 5x1, 3x1 and 4x1. Right. Now considering the third point, that's a constraint. We have the different types of constraint P, Q, R. So we write it for P. We have the constraint P requires A, B, C, all the products, but we have X plus 20. Like it is not required. Sorry, product A is not a combination. Product A do not require the product B. So we write it 0x or we can ignore it. Alright. For product B, it's 20, 20x1 and 30x1. So we take it this way, right? Like this. Whenever the case scenario is given, that convert that case scenario into a table, then you will feel like, wow, this question has become a very easy. You just have to use this formulation. So shall we start with this formulation? Taking the data from the above table only, and then we will start the formulation. So start up, write it over here. Your first point, that is decision variable. What are the decision variable as discussed? X1 will be the unit for product A, x2 will be the unit for product B, and x3 be the unit for the product C. First point. Next heading is your objective constraints. What are the objective constraints? That's Z, profit point. And what is the profit point over here is 534. So write it 5x plus 3x2 plus 4x3. And your next constraints, this is the profit objective, right? Don't write it constraints over here. Just removing this constraint, your objective function. This is your objective function. What is the objective function? Now your constraints over here. What is the constraints? So we have constraints for P. We have constraints for Q. Constraints for R. So what is the constraints for P is? Start writing it. That is equals to we don't require it in the first product. So we are 0 over here, right? So what we write it 0x1, or you can simply write ignore the x1 also. So 0x1 plus 20x2 plus 30x3, right? 20x2 and 30x3, that should be greater than and less than 80. That's a constraint. We have the product for Q also. 20x1 plus 30x2 plus 20x3 should be less than equals to 100, right? And the last constraint, that is 50x1 plus, we don't require over here, so don't write it, or even you just ignore this. And the last one is your 40x3. That should be less than equals to 150. And non-negative constraints are always be there, that x1, x2 and x3 should always be greater than 0. This is the most important constraint. We never take it in a negative constraint. So consider